All right. Good morning, boys and girls. I'm going through the preparatory examination 2025 geography, paper one, geography paper one for Gauteng province. So what I'm going to do now, I've gone through 1.1 and 1.2 on together. I've done 1.1 and 1.2 together. Then I moved on to look at 1.3 on its own. Then after that, I also did 1.4 on its own. The reason being that I don't want you to be confused. I want to make sure that you understand each concept, concept by concept, because sometimes when I cover the whole section, some of you don't have the lenience to go through the whole video, to listen to the explanation, to listen to how I interpreted the question and responded to different questions. So 1.5, refer to the infographic on valley climate in the southern hemisphere below when answering the following questions. So one thing about this question is, one, it has highlighted you the concept, okay? Microclimate, that is your valley climate. Why is the climate of an area different from the surrounding area? Here the focus is on valley climates. Obviously this is part of microclimate. This is part of microclimate. Of course we can include urban climates in that, but here the focus mainly on valley climates. Okay, it has also indicated that it's within the southern hemisphere. So when it comes to them now, including that part of that each is within the southern hemisphere, what they are trying to tell you, to show you, is when it comes now to the hemisphere, what is it that is important? North facing slope in the southern hemisphere are warmer than south facing slope. So that's what should come to your mind. Obviously you know that there's an issue of aspect that is being incorporated here. When they mention southern hemisphere, they are telling you something about it. And even when you look at the diagram, you can see that this one, it shows that it's receiving more sunlight as compared to this one that is in the shadow. So that in itself should tell you. I still feel like there was a mix up here, because this one is supposed to be the north facing, which receives more sunlight as compared to incoming solar radiation as compared to this one that is in the shadow zone. I feel like there was a mix up there, and as far as this question is concerned, because this one, it shows that it's receiving more incoming solar radiation as compared to this one that is in the shadow zone. But however, as long as you know that, it's not a problem. Okay, so this is what we have. Okay, so and same applies with this one. You can see incoming solar radiation, which means it's the opposite. This is supposed to be the north facing because it's within the southern hemisphere. In the southern hemisphere, north facing slope received more sunlight as compared to the south facing slope. That's what this is all about. I think there's need for correction there, because in the southern hemisphere, north facing, here they're saying south north, but this is vice versa. This is your north facing slope. They receive direct incoming solar radiation, and the south facing, they are in the shadow zone. That's basically what we are talking about. So that needs to be corrected, which means this one becomes your north, this one also becomes your what? Your south. There is more insolation on the north facing slope. This is your north, this is your south. Why? Because this is where there is more incoming solar radiation. That's an issue of your aspect. Of course, it's vice versa. There is your north, there's your south. Okay, D is in the shadow zone. Here is where there is more incoming solar radiation. That's the aspect. Okay, so as air cools, air cools, it becomes denser and therefore heavier. The cold air then flows down the side of the valley, resulting in katabatic wind. So we're saying, assuming this is our valley, our katabatic wind, what it does is it is very cold. Okay, it is very cold. As a result of it being cold, cold air is heavy and denser. It sinks. That's basically what we are talking about. That is your katabatic wind. That is your katabatic wind. When it's anabatic, is during the day. What does it do? It rises, which means warm air is light, so it rises, going up. Okay, then what we have here, define the slope aspects. So we are defining what is an aspect, the direction that the slope faces, the direction that the slope faces against the incoming solar radiation. So this is your aspect. Okay, this is your aspect, the direction that the slope faces. That is your aspect. That is your aspect, the direction that the slope faces. 1.5.2, provide evidence from the insolation in the valley. Sketch that the valley is located in the southern hemisphere. Obviously, we are saying now the direction, the insolation of the south facing slope. Okay, the north-facing slope receive direct incoming solar radiation. That's what the north-facing slope are warmer than the south-facing slope. That's what this is all about. Remember, the north-facing slope, I'm talking about number 2 now. Provide evidence from the insolation in the valley. Sketch that the valley is located in the southern hemisphere. This is the north-facing slope. Remember, I've replaced this south with N because it's receiving direct incoming solar radiation. That's why this slope, the north-facing slope, is warmer than the south-facing slope. That's what is happening. That's a reason that substantiates the notion. Direct insolation on the north-facing slope. You can also, the south-facing slope is in the shadow zone. That's basically what we're talking about. At which slope C or D will the shadow zone of the photograph develop? Obviously, it's at D. You can see it's in the shadow. It's at D here. It's at D. Then 1.5.3, at which slope C or D will the shadow zone of photograph develop? That is at D. Then number 1.5.4, account for the difference in vegetation between slope C and D, which is evident on the photograph. You can see here at D, as you can see at D, what is happening at D? More moisture available at D for the plants to grow than at C. Less direct sunlight insolation at D causes less direct sunlight insolation at D causes less evaporation. Why? Because this is a south-facing slope. There is no direct insolation that is coming towards this south-facing slope. Why? Because here there is more direct insolation. So as a result, there is more moisture available at D for plants to grow than at C. There is less sunlight insolation at D causes less evaporation to take place. C. That's why we have got more moisture and more vegetation there. Then at C, there's less moisture available at C for plants to grow than at D because there's more direct sunlight insolation at C, which causes more evaporation than D. That's what you're supposed to do. So any two can answer the question. You must refer to the same characteristic of C and D. More direct incoming solar radiation, which means there's more evaporation as a result of more evaporation, which means less vegetation is likely to be found here. Here, there is no direct incoming solar radiation. There's more moisture, which means there's more vegetation that is prevailing there. Okay, 1.5.5. 1.5.5. It reads, yes, D. Okay, I have answered. Account for the difference in vegetation. We have said there's more direct incoming solar radiation, more evaporation takes place, less vegetation, less insolation at D, more moisture, more vegetation. Refer to the extract on katabatic wind in a valley. Explain how katabatic winds can lead to the development of a valley invasion. Okay, invasion, that's where we have got the increase in temperature with an increase in height. That's what should come to your mind. Of course, when you're talking about katabatic, remember, this is during the night. What do we have? We have got this called, okay, that it is sinking down the valley. Okay, cold air flows down the valley, it slopes and collects at the bottom of the valley. So it's sinking because it's cold, it's denser. That's why it's going down. Okay, then which means that whatever warm air was in here at the bottom of the valley is forced to rise as the cold air is sinking, which means whatever warm air, okay, is left or was left at the bottom of the valley is going to be forced to rise. Remember, these are the air, they've got different characteristics in terms of their temperature. This is cold, that's why it's sinking. So which means here, whatever is here at the bottom is warmer than the air that is sinking. So which means it's going to be forced what? To rise. It's going to be forced to rise, to displace. So this cold air is going to replace, okay, the rising warmer. Let me say, not say warm, warmer, because it's different from this one. It's warmer than this descending cold air. So it's going to be displaced. As it is displacing, okay, of course it is forced to rise. Okay, so warm air is displaced upwards, which means it rises because it's warmer than this. It's warmer. Whatever air is at the bottom is going to be forced to rise because it's warmer than the sinking cold air. Subsiding cooler cold air from above traps the warm air. So we are now saying now, as it is rising, it is going to be trapped in here because there's cold air here. There's also cold air at the bottom. So the warm air is going to be trapped in between, causing a thermal belt. That is the invasion that we are talking about. So there is sinking cold air. What is at the bottom is warmer than this sinking is forced to rise. As it rises, it's trapped now because it's warmer than the cold air at the top, of course, and the cold air at the bottom. That's how we are going to end up having the warm air trapped between cold air, because here already when it's sinking is during the night, cold, calm, nice, it's sinking. Whatever is at the bottom at this point is warmer than the descending cold air. So as it is descending, it causes the warmer air here to rise. As it is rising, remember, it is now trapped with the cold air from above and also the cold air at the bottom. This is what results in our valley invasion, which is your thermal belt. This is what happens, boys and girls. That takes us to question 1.5.5, which takes us to the end of question 1.5. Thank you so much. Have a blessed day.